Hey, Miami scholars. The last few lessons we've been working on angles of not only triangles but quadrilaterals. So today we're going to kind of continue that work and really look at the theory behind the angles, the interior angles of a triangle and the interior angles of a quadrilateral. So if we look at this triangle that we have here in front of us, we can see that this angle here is 75 degrees, this angle here is 35 degrees, and you're wanting to solve for this angle, x. So we want to know what this angle is. And so we can see that this particular angle here is 75 degrees. And if we think about, if we extend this line, so if we extend the line down here all the way across, and you can think about this as a straight line. And you know that a straight line, of course, is 180 degrees. So if you put a point anywhere on the line, so if we have a point here, from here all the way around is 180 degrees. So we know that this half of this angle or part of this angle is 75 degrees. So what would be the missing part of this angle? Well, since you know that a straight line is 180 degrees, this is simply going to be the total, which is 180, and you're going to subtract this part of the angle. So you're subtracting 75. And of course, you know that 180 minus 75 is 105. So this missing angle here would be 105 degrees. Now, that's not the angle that we're finding, but this is important to understanding how the angles of a triangle work. And so if you draw another parallel line, so if we think of this line here as a straight line, and we draw another parallel line along this particular path. And so if we think about this particular line being parallel with this line here. And so what we can do is we can actually take these angles, this 75 and this 35-degree angle. So we can actually take these two angles and place them up into on the exterior angles of this particular point. So this angle here is actually the inverse of this angle. So this angle is 75 degrees. And then this angle, 35 degrees, is actually the inverse of this angle here. So this is 35 degrees. And so we can think about this as a straight line, remember, is 180 degrees. So this is a straight line. Here's my center point. And I have three angles that basically I've taken my straight line, 180 degrees. I divided it up into three angles, 75, 35, and my x, my missing variable. And so if you think of this as 180 degrees, in fact, you can take, and if you had this on a piece of paper and cut these angles out, you would be able to place this angle exactly right there. And this angle would be placed exactly right there. So the missing angle is going to be my missing number. Basically, if we call this A and we call this angle B, and this is angle X. So of course, this 75 here is angle A, 35 is angle B. And so this gives us an equation. A plus B plus X equals 180 degrees. Because the angles of a triangle, the interior angles of a triangle, always add up to 180 degrees. So we can do some simple math here. We can take the 180 degree straight line, 180, and we can subtract our first angle, 75. And we already know from earlier that that is 105. And then we can subtract our second angle. So we can subtract 35 degrees. And we know that 105 minus 35 degrees is going to give us 70. So angle X is 70 degrees because all three of these angles added up gives us a straight line, which is 180 degrees. So X equals 70 degrees. Now, if we take this theory and take this idea of a triangle Always, always, always equals 180 degrees. Now let's transfer that over to a quadrilateral. So we know that a quadrilateral, Q-U-A-D, quadrilateral basically means four sides or four angles. Quad means four. So we have four angles here. 1, 2, 3, and 4. Of course, we can call these A, B, C, and D. Now, when you think about these angles, and this is what I want to show you, that a quadrilateral, if we draw a straight line and we cut this quadrilateral exactly in half, think about if we cut this exactly in half, just like this, we now have two separate shapes. So we've taken our quadrilateral and we made it into two triangles. So here's triangle A and here's triangle B. Now you already know that the interior angles of a triangle are always going to add up to 180 degrees. So the interior angles of this triangle are going to be 180 degrees as well. So here's one angle, here's second angle, and here's the third angle. And this is still going to be 180 degrees because now we have a triangle. This is triangle A, and this is triangle B. So if we think about the angles that we did, we actually cut up these angles. Instead of this being one big angle, angle C, we actually broke it up into two smaller angles. With triangle B, it's this angle, and with triangle A, it is this angle. And so as we think about this, we know that 180 plus 180. So if you have a straight line and you basically add, so if we started here and we added, this is 180, and we add another straight line, of course, we know that 180 plus 180 is 360 degrees. So we've basically created an entire circle. And so this triangle added to this triangle is 360 degrees, which means that the angles of a quadrilateral all added up should give us 360 degrees. And that's really the theory behind triangles and quadrilaterals. I hope this helps you as you continue your work today and work on your practice problems. Have a wonderful rest of your day.